Assalamualaikum and hello to our lecturer and fellow friends. Today we will present our PHY210 video presentation. Our chosen product is a fan and we will explain the physics concept behind it, including rotational mechanics and thermal physics. We will also propose an innovation to improve its efficiency.
Next, let's look at the climate challenge in Malaysia. As we all know, Malaysia is hot and humid almost every day of the year. Because of the high temperature, many people feel uncomfortable and find it difficult to focus on their work on daily activities. Air conditioners can cool a room effectively, but they also consume a lot of electricity, which increase energy costs. Therefore, we need a better fans and more sustainable solution. Fans are a great alternative because they are more energy efficient, practical and reliable, affordable price, eco-friendly and sustainable.
First, looking at section 1, the process starts with the electric motor. When electrical energy enters the motor, it produces torque. Torque is simply the turning force that causes an object to rotate around a fixed axis. More power means more torque. Next, in section 2, when this torque is applied to the fan blades, it creates angular acceleration, which is alpha. This causes the blade to accelerate from rest and start spinning faster and faster. Moving to section 3, as the blades spin, they achieve angular velocity, which is omega. Angular velocity is the rate of turning, represented by the formula omega equal to delta theta over delta t. Simply put, a faster rotation means a higher angular velocity. Finally, in section 4, this rotation results in airflow. Because of the blade shape and the pressure difference it creates, a greater angular velocity directly leads to a stronger and faster airflow. This is how the fan successfully moves air to keep us cool.
Now I will explain how a fan cools us down based on thermal physics. First, the fan creates a steady airflow around our body. This moving air helps remove heat from our skin through a process called convection. Here an interesting fact. Many people think that a fan lowers the room temperature, but that's actually not true. The room temperature remains the same. Instead, the airflow helps our body lose heat faster and speed up sweat evaporation. That's why we feel cooler and more comfortable when the fan is on.
How a fan cools you? Alright, let's move on to this slide, the conversion journey, and see how a fan actually cools us down. First, electrical energy enters the fan when it is plugged in. Inside the motor, this electrical energy is converted into mechanical energy, producing torque that causes the fan blades to rotate. As the blades spin, they generate airflow. This moving air increases heat transfer from our skin to the surrounding environment through a process called convection cooling. As a result, we feel cooler and more comfortable. This same principle is also used in many devices, such as computers and laptops, to prevent overheating and improve performance.
Our smart fan innovation is designed to improve comfort and save energy at the same time. The temperature sensor automatically adjusts the fan speed according to the surrounding temperature. It rotates faster when the weather is hot and slows down when the temperature is cooler. This helps reduce electricity consumption while maintaining user comfort. We believe this innovation can contribute to a more energy efficient and sustainable future.
To sum up, our smart energy efficient fan demonstrates how physics can be applied to solve real-world problems. By combining rotational mechanics, thermal cooling, and smart automation, we can improve comfort while using less energy. We believe that small innovation can create a big impact toward a more sustainable future. Thank you for your attention.
I just had to let you know you're